Hello, this is SND College of Engineering and Research Center, Yeola. Lecture series for first year engineering physics. I, Dr. Chaudhary Vivek Sitaram from first year engineering department. So today's topic is about Hall effect and its applications. The Hall effect was discovered in 1879 by Edwin Herbert Hall while working on his doctoral degree at the Johns Hopkins University in Baltimore, Maryland, USA. Discovered 18 years before the electron. So, what is Hall effect? The Hall effect is the production of voltage difference across the current carrying conductor in presence of magnetic field perpendicular to both the current and magnetic field. In short, when current is allowed to flow through any conductor, and if we are applying a magnetic field perpendicular to it, then perpendicular to the both there is a generation of voltage, that is magnetic field generation of voltage, and that voltage is generally termed as the Hall effect and Hall voltage. I again repeat, when we are in the figure, as we see, when current is flowing through a conductor and we are applying magnetic field perpendicular to it, the direction of arrow B, and the Hall voltage is generated, that is the positive signs and negative signs perpendicular to the both, that is nothing but the Hall voltage. So what is Hall voltage? When current is flowing through any conductor and we are applying external magnetic field perpendicular to it, then to both there is a generation of voltage, that is nothing but the Hall voltage, which is perpendicular to the both, to the current direction as well as to the magnetic lines of flux. So when a current carrying conductor is placed into a magnetic field, voltage will be generated perpendicular to the both current and field. When perpendicular magnetic field is present, Lorentz force is exerted, so which we had studied in previous years, on the electron, due to which electron moves in a perpendicular direction to both current and magnetic field and develop a potential difference across a conductor or semiconductor. So what is Hall voltage? So creates internal electric potential. So Hall voltage is equal to conduction, magnetic lines of flux into current upon number of carriers, electrons, and the thickness of that metal. As there is a Hall voltage and current, so obviously there is a resistance, that is in metals, so RH is there. Creates internal electric potential known as Hall voltage. So Hall voltage is equal to magnetic field applied magnetic field induction into current divided by number of charge carriers to put charge on that and the thickness of the metal along the direction of magnetic field. So in metals, the Hall resistance is equal to EY upon Jx into Bz. But whereas in semiconductor, there is a charge carriers due to electrons as well as holes. So it is charge carriers. According to charge carriers, their contribution is there. So applications of Hall voltage. So it is used as a magnetometer, that is measures the magnetic field. Hall effect sensors is also used as a current sensor, magnetic position sensing in brushless DC electric motors, automotive fuel level indicator, and spacecraft propulsion, and many more applications are there. Now in magnetometers, smartphones are equipped with magnetic compass. This compass measures Earth's magnetic field using 3-axis magnetometer. These magnetometers are sensors based on Hall effect. These sensors produce a voltage proportional to the applied magnetic field and also senses polarity. So you may design the circuit depending on it by using operational amplifier. Now it can also be used as a current sensor. When electrons flow through a conductor, a magnetic field is produced. According to right hand thumb rule, when current is flowing through any conductor, then curly finger indicates the direction of magnetic field. So this has several advantages. So no additional resistance need be inserted in the primary circuit. Also the voltage present on the line to be sensed is not transmitted to the sensor, which enhances the safety of the measuring equipment. So position sensing in brushless DC electric motors. Some types of brushless DC electric motors use Hall effect sensors to detect the position of the rotor and feed that information to the motor controller. This allows for more precise motor control. So automotive fuel level indicator. The main principle of operation of such indicator is position sensing of floating element. When button magnet is mounted on the surface of the floating object, the current carrying conductor is fixed on the top of the tank lining up with the magnet as shown in the figure. So as level of the fuel rises, an increasing magnetic field is there, and on depending on the current resulting in higher Hall voltage. So depending on that, we can come to know that there is the tank is filled up or not.